So next, we will turn to Dan Northrup, who joins us from Benson Hill. And Dan is going to talk about how aquaculture intersects with agriculture. So Dan, please go ahead. Thank you.
Good morning, Karen, and thank you, and thank you, Peggy, for the chance to talk this morning. As you said, I'm in St. Louis this morning with a company called Benson Hill. It's a crop improvement company, and as already mentioned, we're interested in soy particularly, but we'll expand on that here in the talk. So the talk is aquaculture as agriculture, and what I really want to focus on is how the traditional row crop agriculture can help support aquaculture in a sustainable way. Excited to continue working with USDA, and my past role as a contractor with RPE worked in sustainable agriculture for differentiated biofuels, and I think this is another great example of a differentiated crop creating more value at its endpoint. So if you could go to the next slide. I think many people are probably familiar with this book. And I'm sorry, I can't see the bottom of the screen, but anyway, The Wizard and the Prophet, which came out a couple years ago. And this was a twin biography of two people that I think are very well known to most of the people on the call, which is Norman Borlaug, of course, the father of the Green Revolution. And Borlaug was put forward as the wizard who saw technology as the solution to our prosperity and continued growth. And then another individual, William Vogt, who felt that we need to focus on conservation and that prosperity would come through careful use of our resources. The subtitle of the book was that this is a dueling vision of tomorrow's world. But as we were thinking about this and getting into aquaculture, we think, really it's a shared vision, and that if aquaculture and agriculture combine, and I guess, really meaning land-based aquaculture, that it can feed the growing population with fewer inputs without increasing the land footprint. And we want to put forward, I think, in addition to sustainable intensification, that aquaculture is a model of sustainable diversification, and that creates tremendous opportunity. So if you could go to the next slide, then. This is a slide that really goes over a lot of the points that were made by the first speakers this morning. And these are FAO numbers on the growth of wild caught production for fish products and other products from the water. And then the blue bar is aquaculture production. And what you can see is effectively that the wild capture is as large as it's likely to be. And growth and meeting growing demand has to come from aquaculture. So, just repeating the points that it's healthy, delicious, sustainable, and valuable, and extremely efficient conversion process. There's strong domestic demand that could be met here rather than imports. And lastly, coming from the land sector, and I think a lot of I know a lot of the major commodity groups recognize that aquafeed is a high value market for U.S. grain. So if you can go to the next slide. In addition to being an interesting book anyway on the future of the food system, I think The Wizard and the Prophet had a very interesting tie back to aquaculture, which is that when William Vogt got his start, he was working on the sustainability of guano production. And so really this was, obviously it's a fertilizer product for the land. And and he was working on the dynamics of the production of this agricultural commodity. So he looked at the seabird populations, which supplied the guano, and they in turn were supplied by the anchovy migration. And of course, this is a major part of aqua feed and a large part of the wild captured fish. And as we look, going forward, this link will continue, but maybe slightly reversed. So now, rather than moving from the sea onto the land as nitrogen, there's an opportunity for plant-based materials and land-based proteins to enter aquaculture and maintain the health of the oceans. So, going into the next slide, please. What this really means is that scaling aquaculture requires sustainable feeds. And sorry, I just can't see the bottom of my screen here. Starting here kind of with a quote from Rick Barrows, a retired USDA researcher and still working in the area, that sustainability of the oceans, the earth, and aquaculture is the reason to work on this, and nutrition is the way to get there. So as the industry moves away from using fish meal or reducing its fish meal impact, there's a challenge in ration design that's a combination of nutritional science and materials engineering to make a ration that's nutritionally complete for protein, vitamins and minerals, as well as energy to support growth. Those rations have to be highly digestible and support water quality of the system to maintain a low impact. They need to be palatable for consumption. There's a challenge that we'll talk about of anti-nutritional factors that can come in with new food sources. We need fats in particular that support fish health and human nutrition, as Peggy spoke about. And then lastly, on the materials science side, having a pellet that stays together and retains the nutrients that were put into it. So if you could go to the next slide. There's already been an economic imperative to reduce the amount of fish meal put into fish meal and other fish products that are put into rations. So taking some data from MOE's salmon production guide, here on the left, you could see their progress in reducing fish oil and fish meal in salmon rations, where in 1990, close to 90% of the ration were based on fish products. Now here in 2019, 2020, it's closer to a quarter. Taking this a lot further, or all the way further to its conclusion, there's a group of researchers in the Fish-Free Feed, F3 Feed Innovation Network, that are looking at the ability to save forage fishes by replacing different components of the diet. So the first challenge, which is complete, was any ration that was fish-free. And then second challenge, removing fish oil, and very successful and high impact. And there's an ongoing challenge right now to replace all fish products in carnivorous fish diets, which is the most challenging. So the next slide. And a lot of that challenge relates to the fact that plant meals and other proteins aren't part of the diets of fish in the wild. And so there's a need to make sure that, of course, there are many components of fish meal, and reconstituting all of that nutrition in a new ration requires research. Soy in particular is a sustainable, scalable, and nutritionally balanced and affordable protein source. But unfortunately, trying to bring plant meals into fish rations at high levels, many researchers noted that this can lead to a gastric distress or enteritis that causes growth suppression and economic loss. We know, and discuss this, that the enteritis is caused by non-protein components in the plant. The disease can be diagnosed by histology, as you see on the right, so a normal gut on the top and a diseased gut on the bottom with the inflammation, as well as other molecular markers. The industry does incorporate a lot of soy protein, but it does this as soy protein concentrate, which is a purified form of proteins that reduces anti-nutritional factors and increases the protein concentration. So on the next slide, the goal is to continue to further innovate in sustainable and economic feeds for fish. And we looked at this, that really there are two approaches, and USDA has been extremely active in both. So this is to optimize the fish's genetics for modern diets and modern production systems, and then also to work on the feed side. Within fish improvement, this relates to productivity, growth rates, disease resistance, and then a very interesting approach coming from USDA that we'll talk about of breeding to the diet. And then on the feed side, it's diversification. There's tremendous opportunity for impact or potential for impact in this. Feed is up to half of the cost of fed aquaculture and up to 80% of the environmental footprint. So by improving this aspect of the system, we have a great chance to improve the overall sustainability. Next slide. So I wanted to talk first on the fish genetic side. This is now nearly a 20-year-old experiment called Trout Grains, run by Ken Overturf, USDA-ARS. Thank you to Ken for these slides. It was a breeding program to select fast-growing rainbow trout individuals with a focus on doing this on plant-based diets. So as you can see from the plot on the right, they initially started with a diet that comprised 15% soybean meal. Now are feeding diets up to 25%, and I believe even higher soybean meal. And within this breeding program, they successfully doubled the 5-month wait. This is an extremely valuable economic trait that shortens the time to market. And these genetics have been taken up by major trout producers. If you go to the next slide, the team was able to demonstrate that selective breeding could enhance growth specifically on a plant-based diet. So these populations were kept separate. Many of the fish were selected on the plant-based diet. That's the gray bar. Other fish were selected using traditional ration. And then when those genetics are grown on a plant-based or more conventional or traditional diet, what you can see on the left is that there's significantly lower growth, demonstrating that this is a real possibility. This is borne out in the molecular and histological markers of disease, so that the fish selected on genetics grow faster on the plant-based diet, have improved gut morphology, lower cell proliferation and inflammation, and enhanced digestive function. So on the next slide, leaving then the fish side, I think that rainbow trout is a model for many species and the success that breeders can have on the animal side. On the feed side, which is where Benson Hill is working right now, there's the potential for many new protein sources. We focus on plant proteins. Of course, there's animal byproducts, insect meal, single cell proteins, and then in fats, great potential to replace fish oil with plant oils, engineered plant oils, and algal oils. So on the next slide, going into what Benson Hill is working on and continuing work from USDA-ARS as well as other breeding programs, Benson Hill is commercializing lines that have a high level of protein and ultra low oligosaccharides. What we see on the right is the biosynthetic pathway for oligosaccharides, which are present in soybeans and most plants. These compounds are indigestible to monogastric organisms, including fish, called raffinose and stachys. And as an anti-nutritional or indigestible compound, it may contribute to the gastric distress. And so the goal of this breeding program and carrying it forward is to develop low anti-nutritional traits with high protein and really produce something in the field that looks a lot closer to soy protein concentrate and therefore will be a good dietary source of protein for aquaculture. So if we could go to the next slide, real quickly, what's going on or sort of up to date with this work is testing still the digestibility of the most developed strains that are being produced right now. It comes in as an ingredient that looks like soy, but is soy, but has higher protein, lower anti-nutritionals, depending on the processing. And I think, all of these are interesting levers that aquaculture can pull. It can bring some fat and energy with it if it's expeller pressed and maintain the protein level of the commodity soy, or by removing the excess oil, it can be a higher protein ingredient depending on the needs of the nutritionist. I unfortunately, without being able to point at the slide, I'll just say, that the digestibility indicates that the protein is as efficient as other soy ingredients, not significantly different. And may provide advantages for dry matter digestibility and a little bit more energy, bring a little bit more energy to the diet. On the next slide, this material was also tested previously by Alex Buentello, and then in collaboration with Gary Burr of USDA-ARS, all funded through USDA NIFA SBIR work. And what they showed is that diets, and this is the light blue bar, containing the high protein and ultra low oligosaccharide soy performed similarly to conventional diets based on fish meal or SPC, and that can be seen either in the feed conversion ratios or the weight gain over the 16-week grow-out period. One thing I want to highlight and just visit on this at the end is that that there are differences in ways that the fish process this, so that the fecal particle size was different from when including the ultra low oligosaccharide meal, and I apologize, SPC, under the white box on the right, where what you're seeing is that the particle size is small, and depending on the production system, this might be an advantage, or it may need to be addressed with other feed additives. So on the next slide, with those previous grants, the team was able to test in several species, including salmon, trout, yellowtail, Pacific white shrimp, and cobia. Never saw evidence of enteritis in those systems, and the material may provide energy advantages and dry matter digestibility. I want to say this is only the first trait. Of course, there are many potential things that could be done to improve soy further. So the company's exploring gene editing to address other anti-nutritional factors. And we hope that this is just the first of many traits that are specifically designed for aquaculture. On the right, I wanted to highlight quickly, this is a test in yellowtail, and the diets, the improved soy diets are in orange and green there, and they're shown here outperforming commercial diets. And I think what this reflects, of course, we believe it's a great ingredient and it supports growth, but just that the commercial diet isn't tailored well to yellowtail. And so there's a great opportunity through nutritional research to improve the productivity of any species. If you go to the next slide, as we think about the value chains that this type of product or a differentiated protein within the commodity chain can support, starting in the middle, if you can replace soy protein concentrate with soybean meal, it has a significantly lower processing footprint. And what that means is that it also, the farmer is producing more of the processed value, and there's an opportunity for more economic impact at the farm growing these genetics. The supply chain has great traceability, so visibility all the way back to the farm, meaning that if the downstream players are interested, or depending on what the markets are, so we're very excited about the USDA leadership in carbon markets and other ecosystem services, that the farm can convert to regenerative agronomy or other practices that are more sustainable, which will improve the overall efficiency of the aquaculture system, both in emissions and water quality. And so then if we go to the last slide, we want to leave it, sort of with a vision of what we believe is sustainable diversification. If you go in, this is a line from Russ Houston, that the animal production system is highly consolidated. And if you look at animals, only 3 species comprise about 80% of animal production, whereas within aquaculture, that's more than 70 species to get to the same fraction of the industry. This requires nutrition. It's a line that Alex told us, thought was interesting, for nutrition for everything from a cat to a cow. And I think there's great interest in maintaining that species diversity, and that will allow us to take advantage of the wide variety of production environments and consumer demands. There's the exclusive economic zone from the Gulf of Mexico to Alaska. Very excited at the USDA's expansion into marine fish and recently from ARS. In addition to that, tons of excitement about blue houses on the land, so indoor land-based aquaculture, as well as land-based ponds. Coming then from USDA, and then the request is the capacity to create and research custom diets for each of these species. That requires small-scale infrastructure, including feed mills, to produce these diets, testing out many more ingredients, faster ways to monitor the health of the system. Really species-specific farming systems here, but different farming systems within species that might fit each environment. We believe in doing that, there's a path forward to produce much more food in a way that sustains both the water and the land, and may connect some of the traditional row crop acres where we are here in the Midwest to the coast and to the water. So with that, I'd like to wrap up. Next slide. I have some acknowledgements. I think sort of standing on the shoulders of giants here, and a ton of USDA work in the past with Rick Barrows, Wendy Seeley, and Gibson. Thanks for data from Ken and Gary. Alex Buentello did a lot of the initial characterization, and then my colleagues at Benson Hill. So thank you again for the opportunity to speak, and we look forward to working more with you.
Thank you, Dan. Great presentation. You showed us a lot of the connections of aquaculture and agriculture, and even some of the partnerships across USDA, ARS, NIFA, and the private sector. Dan, if I could ask you, we have one question, if you wouldn't mind. We have Lucy Lee, who has asked, what is the impact on the omega-3, omega-6 ratios by replacing fish meal with vegetable protein?
Thanks, Lucy. And I apologize, this isn't exactly my area. My sense on the protein side is that there isn't, and that comes from the oils that are included in the diet. So it is important to feed those ratios, and going into the F3 Fin Network's work on how they were able to replace those different fats, particularly with algal oil, and maintain the ratio of a wild-caught fish, is what was happening there. So on the protein side, I think not very much. On the oil side, great point that has to be, it needs to be investigated. And I didn't mention a lot of this is characterized both for flavor and composition, ensuring that it still has the same nutritional value as a wild-caught fish.
Okay, thank you.